Hello, welcome to another episode in the PWA series. So in this episode, we'll look at different caching strategies. So most of it will be theory. There won't be any coding in this episode. But we will be looking at a nice article from the folks at Google on how to cache files in the service worker. So they do have some sample code under each of these strategies. So we'll look at that code and also some visualization for better understanding of each strategy. So without further ado, let's just get to it. Okay, so here is the article that I told you about from Google. So it has all the details that are needed to understand how to cache different files in a service worker. So if we scroll down, so here are the different strategies that they have listed, like cache only, network only, cache falling back to network falling back to cache, and finally cache then net. So we'll look at each of these strategies, and as you can see, they have given some description and also some sample code. So additionally, I have prepared some visualization like a diagram with the flow for better understanding. So let's get started with the cache only. So here we'll just use the cache to access the resource or to cater the fetch request that the service worker intercepts from a web page. So with the code here, you can see that it is responding with a matching resource from any of the caches. So the caches gives access to the cache API, if you can remember from the code that we wrote in the previous two episodes, or the static and dynamic caching. So once it finds a match for the input request from the event object right here, it just returns the result of that match and sends it back to the web page. So the cache only strategy would be perfectly suitable for the static resources because they're actually added to the cache right at the installation of the service worker and won't be needing the network. So let's look at this in a diagram. So here is a diagram that tries to capture the essence of the cache-only strategy. So here I've put in A and B. So these are like the requests made by the web page directly through the cache API, and the B is an indirect request through the service worker. So I've also numbered the sequence of steps with some brief description on the side. So one thing about the Cache API is it can be accessed from a normal web page too, and not only a service worker. So for that reason, I made this a distinction here. So one possible scenario is the web page directly accessing the cache for a resource and it gets back the response. And the other scenario is by making a request to the service worker. So that is the first step there. And once service worker intercepts that fetch request, it makes another request to the cache through the Cache API. And once it receives the response back, then it serves back that response to the web page. So that completes the cycle. So this is kind of equivalent to the offline state of an app. But even when it is online, the idea of this strategy is to never reach or make requests to the internet. So that is the cache-only strategy. And in all these strategies, the visualization, we'll be using these four entities: the web page, cache, service worker, and the internet. So like I said before, this will be only suitable for the static resources, but for dynamic resources, the app will have to access the internet. So with that, we have the second strategy, which is network only. So if we look at the sample code here, so it's directly making the fetch request to access the internet and get the response for the given request. So which is then forwarded back to the web page. So the network only, it's kind of the default state of any app that you create without any PWA features, because by default, we always try to get resources over the network. However, because it is strictly network, even if we have caching, with this strategy, we will never access the cache and thereby cannot leverage any benefits like the speed or the offline functionality. So if we go to the visual representation, so again, I have two scenarios where the web page can directly make a fetch to the internet and get back a response, or we can have that fetch handled in the service worker and have the sequence of steps with the first step being the request made by web page to the service worker, and the step 2 being the request to the internet, getting back the response, and then forwarding it to the web page in step 3. So as you can see, the caching is not available here with this strategy. So we won't be using network only for different resources because we want to take benefit of caching resources. So for that reason, this is not commonly used as a caching strategy in a PWA. So let's get to the next strategy, that is cache falling back to network. So with this strategy, we use both cache and the network. However, the first step is to access the cache directly. So if you look at the sample code here in the fetch event handler, so we first access the cache, we look for a match for the input request in the event object, and if we have a valid response, we just return valid response here, and if it is not valid, then we fall back to the network making that fetch request. So does this look familiar to you based on what we discussed in the previous episodes? Yeah, so this is basically the strategy that we implemented with the dynamic caching there. So we first look for any cache response in the caches, and only when there is a cache miss, we make the request to the network. However, even though we have the benefit of the speed of the cache, if the resource is cached, we have the drawback of not having up-to-date resources. So let's say some change was made to the resource over the network. We will always access the cached version, but we never update the resource to the latest version. So let's look at this in a diagram. So with the Cache-With-Network-Fallback, we have the web page here. So it starts off by making the request to the service worker, and then because it is cache first, so it makes the request to the cache via the cache API in step 2. So depending on whether the resource has been cached or not, there are two possibilities for step 3. Either we get a cache hit, meaning the resource is available in the cache and can be readily served by the service worker, or there is a cache miss and we have that extra step to make a request to the network and get back the response before it can be served to the web page. So just to differentiate the two possibilities, I've used a different color code. So when you have the cache hit, you just get back the response in step 3, serve it in step 4, the web page. And if it is a cache miss, you get back the indication that you have a cache miss, and you make the request, get a response in step 4 to the service worker. And once you have the response, it is served by the service worker back to the web page in step 5. So you can also do some dynamic caching, like when you get back the response from the internet. To avoid any future network requests, you can actually add it to the cache, which we do with the dynamic caching, and then send back the response. However, like I said, we have that drawback of the resource not being updated if at all there is any change in the network. So we have the next strategy, which is network falling back to cache. So in this strategy, it is network first. So if we see the code here, it is doing the fetch first, and only if there is an error, meaning like if the app is offline, then in the cache block we're making that request to the cache. So we just change the order in which we make the request to different resources. So this does fix that issue of not having the latest version of a resource or data that is likely to change more frequently in the app. However, the drawbacks would be with the speed, of course, because even if the resource is cached, we always make the request to the network. So only when the request fails for some reason, then we go to the cache as the fallback. So we won't be able to fully leverage the benefit of the cache. And another drawback is, if at all the network connection is kind of slow, it will take some time for the request to fail, and only then there is a possibility of getting a cached response. So that can actually lead to a bad user experience, like it's described here. So if the user has an intermittent or slow connection, they'll have to wait for the network request to fail. So this can take extremely long and can be a frustrating user experience. So just to make it more clear, let's go to the diagram again. So network with cache fallback. So the web page, it makes a request to the service worker, and we have the fetch intercepted there. And then because it is network first, it always makes a request to the internet. And depending on whether we are online or offline, there are two possible sequence of steps there. So if we are online, we can readily get the response back, and the service worker can serve it back to the web page in step 3. However, if we are offline, the service worker will have to reach out to the cache via the cache API in step 3, and once it gets the cache response back in step 4, then it can be served to the web page as part of step 5. So again, we have the distinction between the two sequences with the blue and the brown lines. So again, with the intermittent network connection, if at all the request fails after some time, the user will have to wait for the response to be fetched from the cache, leading to a relatively slow page rendering and possibly a bad user experience. requests. So we have the next strategy, which fixes this by getting both the speed with the cache and also the latest content from the network. So that is the cache then network strategy. If we look at the sample code here, so we're making a fetch request. So we get the response here, which is a JSON response in this case. So once we get the data, we update the page with that data. So you also see that there is a flag here, network data received. That's because right when you make the network request, you also access the cache simultaneously. So we request the same resource, data.json, in both the fetch call and also the match for the cache. So typically the cache response would be faster compared to the network response. And if the data is available, it will be readily rendered and the page will be updated. So that fixes that lag that you might have with that network connection. So you'll have the user engaged on the page right away. And later on, when we get the network response after some time, then the page will be updated again with the latest data, if at all there was any update. So if you look closely in the code for the cache here, so it checks for that flag, network data received. So it updates the page only if the network data hasn't been received yet, because it doesn't want to override the latest data with the older data in the cache. So this is more sophisticated compared to all these strategies we saw previously, because we get the instant response from the cache, keeping the user happy. And if at all there is any change in data, we do get that after some time and the page is updated again. So let's look at this in the diagram as well. So cache then network. So here you see that in the first step, we have the request to the cache and also the request to the service worker. So this will be the network call and this will be the normal cache request. So the web page will be readily updated with whatever the response we get from the cache. And then once we get the response from the internet, the service worker actually saves it to the cache as well in step 3, so that it's available for any future requests, avoiding the network call. And once it's added to the cache, it then sends the response back to the web page. So if at all there was any change in the resource over the network, you will see that change on the web page. And if it doesn't change, it just stays the same. So I think this is a more complex and also sophisticated method to take advantage of the cache speed and also get the latest version of the resource from the network. So I hope that gave you a good understanding of the different caching strategies that are available. So with the static and dynamic caching that we implemented in the previous episodes, we have implemented just the Cache-With-Network-Fallback or the dynamic caching, but it's also possible to implement other strategies depending on the resource, like we have the static cache. So just when rendering resources from the static cache, we could use the cache only strategy. So that way we can have some conditional resource rendering with the different caching strategies. So for the products and the favorites data that is available, that is actually dynamic content. So for that, the cache then network would actually be more appropriate. However, because we don't yet have a backend, we won't be able to use it right now. But once we add a backend, we would be able to incorporate that strategy too, but that is for the future episodes. So since we're done with the theory in this episode, in the next episode, we'll look at how to make changes to our current e-commerce app and take advantage of different caching strategies. So if you found this video helpful and are interested in this kind of content, do consider liking this video and subscribing to the channel, and there is more content coming along. So thanks for watching and hope to see you in the next one.